Okay, hello then. So, Jumpstart, for those who want to start coding in Kotlin. 30 minutes Jumpstart. Let's begin. So first, I want to tell you a bit more about Kotlin. Kotlin was developed by JetBrains, and it is a programming language that today you can use it not just for Android. There are many other usages. I believe most developers heard about Kotlin in the context of Android, but actually, based on my experience delivering courses on Kotlin, most of the developers I meet use Kotlin on the server side. They develop in Kotlin. The code is compiled into Java bytecode, so it is very simple to integrate something you developed in Kotlin into a system that already exists, a system that was developed in Java. However, there are other options. I'm less familiar with those options. They are not popular as the one I've just described, but they exist. For instance, you can code in Kotlin and transpile the code into JavaScript. Um, I'm not going to do it. I prefer TypeScript. I think most developers prefer TypeScript when it comes to the web browser or to code something in JavaScript and avoid JavaScript, then TypeScript is the preferred option. Developing applications for Android, well, I used to do it. It used to be my main domain many years ago. Today, the Android platform has so many um, possibilities to develop. I mean, there are so many technologies you can use to develop native applications or applications in general for Android that developing a native application is no longer the main option. You can develop using Dart and Flutter. You can develop using native script, React Native. You can develop using Xamarin coming from Microsoft. You can develop hybrid applications. You can develop using Unity. There are so many possibilities that developing a native application is an option, but that becomes less and less popular. So it's not my domain anymore. There is the Kotlin native option, meaning you develop in Kotlin and you compile the code in a similar way to compiling code developed in C++. So you get binaries you can execute directly on the platform for which you develop. There is an option to develop in Kotlin and transpile the code into WebAssembly, WASM. There is an option that JetBrains promote to use Kotlin for developing applications for multiple platforms, mainly iOS and Android. Well, for the same reason that I don't like, I'm not into the domain of developing applications for Android using Kotlin. This is the same reason why I stay away from using Kotlin for multi-platform. There is an option to use Kotlin for data science stuff. Well, I don't think that there is a good, well, maybe they succeed in a way, but today Python is very dominant, so I prefer Python. So bottom line, I prefer using Kotlin on the server side instead of Java or alongside Java. Both ways are okay with me. And this is also what I see mostly usually in companies that adopt Kotlin. They start using Kotlin on the server side alongside Java or instead of Java when there are platforms with lots of microservices, then they start developing specific microservices in Kotlin. It happens a lot. What about the popularity? So it is Kotlin won't be popular as Python. Don't expect it to happen. It won't be popular as JavaScript. It can't be. Kotlin is more difficult to learn comparing with Python and JavaScript. However, if you check the static type programming languages that are available today, such as C++, Java, C#, and so on, then Kotlin is an option. And if you compare Kotlin with Scala, then you will find that even though Kotlin was born after Scala, Scala was born in 2009, and Kotlin, I think it was born, the first release was in 2014. So even though Kotlin is newer, it is more popular than Scala. Kotlin today, according to the TIOBE index, is in place 19, Scala 32. So this is an indication for something. And based on my experience learning and using Scala, and I started using Scala in 2009, Kotlin was simpler to learn. Maybe it was due to the fact that I already knew Scala, and Scala and Kotlin are very similar. But even when I try to neutralize this fact, I still have the feeling that Kotlin is simpler. Um, the toolbox in Kotlin is a bit smaller comparing with Scala, and the documentation is a bit better comparing with Scala. At least this is my feeling. About the learning curve, so Kotlin, Swift, and Scala are very similar. If you know one of the three, it would be very simple to learn the others. It is highly recommended to know Java before you start learning Kotlin. If you know C# only, uh, well, C# and Java are very similar. It still might work. Would be okay. But if you don't know neither Java or C#, learning Kotlin as the first programming language, well, I don't recommend doing it. Mainly because most of the tutorials and the documentations you will find for Kotlin are for developers that already have some background in programming. So it would be best to know Java in advance, and if not Java, C# would be fine as well. If you already know Java, then moving forward with Kotlin, I think it would be simpler comparing with Swift and Scala, at least based on my experience. What about the IDE? Well, the simplest option would be using IntelliJ. Yeah, just download IntelliJ, start a new project, specify you want to develop a Kotlin project, and that's it. And the wizard will create a project you can use to start coding in Kotlin. Everything you need, it will be automatically downloaded. So it would be very, very simple. In this screenshot, you can find code sample. Well, I can move to the IDE itself and show you how simple it is. Let's create a new project. So you just new project, and then you specify I want a Kotlin project, and then you type the name of the project. You can select the build system, and then just click create, and it works automatically, usually without any problem. You just need to specify if you want to open the project in a new window or the same window. So let's use the new window, and then I will close it. Okay, so this is it. And then you can start coding, very simple. You create a package, just as in Java. And then if you want to create a file that is a class or just a file with some code in Kotlin, that's it. And then you start coding, as I did here. This is a simple program in Kotlin. Here you can see a definition for a class. Its name is rectangle. The primary constructor in Kotlin is bundled with the class declaration. It is the same in Scala, by the way, and you can mark a class as a data class exactly as in Python. So automatically there will be more methods that will be generated for this class. If you specify val or var for those two parameters of the primary constructor, then these two parameters won't be just parameters of the primary constructor. They will also be properties that each and every new object instantiated from this class will have. So here you can see I create a new object from the class rectangle. We don't use new, which is very similar to Python, very similar to Scala as of Scala 3. We don't use new, we just specify the name of the class. And then we can pass over values to the parameters. We can specify the names of the parameters that are going to get each and every value, very similar to Python, Swift, and many other programming languages. And then when I try to print the object to the screen, the toString method, as you probably know it in Java, C#, in Python, we have the underscore str method. This is the method that will be invoked. And because we mark this class as a data class, we have that method generated for us. So we will get something printed to the screen. And you can see that it will be an output that describes the object. Okay. So let's get back to the slides. As you saw, it's very simple to start coding in Kotlin. The main website is kotlinlang.org. This is where you can find the documentation and more resources. Okay, so I've just showed you that we use packages. Packages in Java is just as namespaces in C++ and C#. They do the same job. And now about defining new functions, you already saw that we use the fun keyword for defining new functions. Here is in this code sample. Now, as you can see, the type of each parameter is placed right to the name of the parameter, not on the left, but on the right side. And you can also see that we specify the type of the return value on the right, not the left side, but on the right side. And if the function is just a simple expression, then we can easily take away the curly brackets and just specify the expression using the equal sign, and then the function sum will be created. The compiler automatically understand that the type of the return value is int, so there is no need to specify that. If the function doesn't return anything, then we can specify that the type of the returned value is unit. Unit is the equivalent to void, what you are already familiar with in
בסדר, אני אספר לך תכף, אני רוצה להתחבר לאיזה זום.
unit is the equivalent to void. Void, I believe you are already familiar with in C# and Java. And if the type of the return value is unit, you can take it away. As you can see over here, the function main, we don't specify a unit. When you define local variable, you specify val or var. If it is a constant, then specify val. Kotlin is a static type programming language. Even though in many cases you can avoid specifying the type, it is not JavaScript or Python. It's not a dynamic type programming language. When you don't specify the type, then the compiler understands the type automatically. It's very similar using the keyword var in C# and in Java. In Java as of version 10, you can create a new variable using var. The compiler, if it is a local variable, of course, the compiler will understand automatically the type of that variable. Now let's move forward. Let's move forward. Comments, as you can see, just as in Java. We have if statement, if else. However, in Kotlin, those statements are actually expressions. So you can do the following. You can assign an if expression to a variable, and then the value of that if expression will be assigned, in this case, to the variable temp. As you can see, I didn't specify type of temp. The compiler understands that automatically. Now, about null. Well, there is a good article you can find on the web. Its name is Null $1 billion mistake, something like that. We can easily find it. Just look for null $1 billion mistake, and there are articles about this, about the mistake, that happened when null was invented. And the reason is that this is the man, Tony Orr. He invented null long time ago. And the reason we call it a mistake is because many, if you look at systems developed, system you were involved with their development, then you can see that there are many cases in which developers need to find bugs and overcome problems caused by the fact that a variable holds null and not a reference to an object, and because of that we had exception, and because of that the system didn't work, the software didn't work as expected. So bottom line, those that developed Kotlin decided that Kotlin won't support null. There is no place for null. However, because we still need to support null when we are interacting with code developed in Java. After all, code in Kotlin is compiled into Java bytecode. So it is very simple to code something in Kotlin and use a library developed in Java. So in those cases, we need the support for null. So by default, we don't have a support for null. If you need to have a support for null, then you add the question mark to the type. And by doing so, the type becomes a nullable type. And only then it is possible to use null, as you can see in this case. Sorry for the interruption. Okay, let's move forward. The loop, the for loop. Well, it is supported in Kotlin, and it works very similar to for each. We have a support for while. The plus plus and minus minus operators are supported. The when expression allows us to use the switch case statement with more possibilities. Many will say that the when expression is actually a more sophisticated switch case statement. However, it is far beyond just a switch case, and there is it allows us in Kotlin to support what we know as structural pattern matching. It is something that already exists in Python. It is already supported in C#. In the recent versions of Java, it is already supported in Java. It is supported in Scala. And it allows us to develop smaller programs. I'm not going to explain what a structural pattern matching is. If you are familiar with it, then you can now know that Kotlin supports structural pattern matching. Okay, next. We have a support for range and collections. We have various collections we can use. List, dict. Okay, I'm not dict, it's a map. Let's move forward. Okay, when it comes to object-oriented, then defining a new class, we do it using the class keyword, as you saw. And in a minute, I will go deeper in this domain, this topic. But first, let's talk about the types. Well, when dealing with values in Kotlin, you always deal with objects. Every value in Kotlin is represented using an object. Even the primitive type values, int, float, you are dealing with objects instantiated from classes. Always objects. And due to that fact, there are various limitations that you will learn when learning Kotlin properly. Not now. Now I'm just trying to give you a small jump start. Kotlin supports arrays, of course. And the syntax is very similar to what you are already familiar with. Strings, of course. Now let's get a bit deeper into the classes or object-oriented domain. So defining a class, you already saw, we do it using the class keyword. If we want to bundle together with the class declaration a primary constructor, then we do it by specifying in brackets the parameters, and we can add the keyword constructor if needed. Here, for instance, I took the word constructor away, but if you want, for instance, to specify a different access modifier to the constructor, then you must have that keyword, the constructor keyword. Well, if you want secondary constructors, then you can define them, and usually they will include a call to the primary constructor. If you need code in your primary constructor, you need to add the init blocks. Those blocks will include code that will be executed whenever the class is instantiated. Okay, what else? Here is a secondary constructor. As you can see, it is very simple using the this keyword to invoke the primary constructor. You can define a class that extends another class, but you should remember that all classes in Kotlin by default are final. So if you want to define a class that extends another class, you must use the open keyword and put it before the definition of that other class. For instance, if you want to define derived as a class that extends base, you must specify the keyword open in the definition of base. The same with methods. All methods in Kotlin are final by default. So if you final means that you cannot override them. So if you want to override a method, first you need to add the keyword open to the definition of that function you want to override. Okay, now about properties. Well, in Kotlin, when you define a class, and it seems that you define a class with variables. For instance, let's take a look at the rectangle class. These two variables are actually properties, not variables. And a property is a shortcut for a setter and a getter. If you are familiar with properties in C# or Python, it is the same in Kotlin. Just that in Kotlin, when you define a class, you can define properties in that class. You cannot define variables. So, for instance, take a look at this definition for the class rectangle. Here I define in detail two properties, width and height. And actually I defined three properties. The area property includes just a getter. The width and height include getter and the setter. So when you refer, when you instantiate a rectangle and then you refer width in order to assign a value, the getter will be invoked. If you refer width in order to get a value, the setter, vice versa. If you refer the property width in a class, in an object that you instantiated from rectangle, if you refer that property for getting its value, then the getter, the get meaning will be invoked. If you refer width in order to assign it with a value, the setter will be invoked. Okay, let's move forward. You can define interfaces. And you can include in that interface, you define methods with implementation, similarly to interfaces in Java as of Java 8. It is possible. When you define a class, the class can extend only one class, but it can implement as many interfaces as you want. We don't have a special syntax for implementing an interface. You treat the interface in terms of syntax just as if it was a class. So here I define a class, its name is student, and I specify that student implements printable, and I do it using the column operator, just as if printable was a class. The same syntax is being used in both cases. Visibility modifiers, public is the default. It is similar to what you already know in Java or in other programming languages. Let's move forward. Okay, data classes. We already saw that, the support exists. Very useful. Similarly to record classes in Java or data classes in Python. Now, when you define a class and mark it with data, automatically methods will be generated. For instance, the toString method, as you can see in this code sample. Now, sealed classes, if you want to specify a class that it would be possible to extend only by specific other classes, you can achieve that by marking that class as a sealed class, and then only those classes that you define in the same file will be able to extend that sealed class. Highly useful when dealing with pattern matching. Highly useful. I think the support in Kotlin is very similar to what you can find these days in Java when it comes to sealed classes. Okay, here is a simple code sample for class and other classes that extend that class, and due to the fact that the expression class is marked as a sealed class, we can be sure that the only other classes that extend expression are the ones we see below, the ones that are defined in the same file. And based on that, we can use a structural pattern matching, as you can see over here, and compare OB with those specific types that are the only types that extend expression. This is something you can achieve only thanks to the fact that expression was defined as a sealed class. Okay, so it was fast, but the purpose was providing you with fundamental knowledge you can take with you moving forward when learning Kotlin. More resources you might find useful so there is the Kotlin course I deliver. Here is a link, you can find more details. Currently delivered in Hebrew only, but if a demand exists, I can open a group in English. Here is a link to an online conference I manage every year, so you can just find the details inside that link. Java Monthly Review is a new newsletter that focuses on Java. You can join it for free. If you check out my company website, lifemichael.com, you can find it in 2 languages, Hebrew and English. You can find more information about courses, including courses on Udemy. Lots of courses on Udemy in many topic domains. And you can find more resources. When talking about courses, you can also find courses that were already recorded in Hebrew. Check the Life Market Professional courses in Hebrew that I've already recorded, so they are cheaper, and that's it. Okay.